Thank you. Hello, everybody. Lovely to meet you. So, as you heard, my name is Daniel Frith. I'm Chief Creative Officer of London Dynamics. I chair the 3D Commerce Working Group, which is a working group where we look at what the industry needs around e-commerce and retail using 3D in real time. I also vice chair on the 3D Formats Working Group with Alexi there, where we look at GLTF and PBR and things like that. I'll introduce you first to Ashley.
Hi, I'm Ashley Crowder. I'm the co-founder and CEO of VNTANA. We're a 3D asset management platform that makes it incredibly easy to view, manage, and publish 3D everywhere you need.
Hello, I'm Paul Connelly. I work for Bentley Systems. We develop software for the people who design, build, and operate the world's infrastructure. And a big part of my job is the 3D visualization of those infrastructure assets.
Well, I'm Eric Chadwick, a senior 3D technical artist at DGG, and we make Rapid Pipeline, which is a conversion and optimization platform for 3D assets.
We're here today to talk to you about what it means to convert CAD data to visualization and for use in commerce. The reason we felt this was an important thing, it's come up as many times a question to us about there's lots of different ways in which CAD comes in, lots of different formats for CAD, and today we're going to dig into a lot of that stuff and some of the use cases and some of the pros and cons and some of the key objectives and that everyone needs to assess when using this. But actually we had a little poll to do first. We kind of want to get a raise of hands of, now it might not be every industry in here and I do apologise, but how many people are from the automotive industry in this room? Okay, 5. And in gaming, 1, thank you. Commerce, okay. Architecture, wow, yeah. Medical, okay. Wow, it's really mixed. It's really good. And any other industry? Maybe some, wow. Can I ask you what those industries are? You able? Art and design. Defense, okay. And do you all use CAD in part of what you're doing in your day-to-day Wow, okay, interesting. We didn't add those industries in. We would like to talk to you a little bit about what are the key challenges and processes around that. I'll start and then we'll each take a turn and go through some of those use cases. One of the biggest challenges that we found at London Dynamics, as an example, is a lot of clients have CAD data for manufacturing or design, but they come in many different types of file format, right? So we've got anything from a DWG file to a Parasol Siemens XT file, a DXF file, a solid assembly or a solid parts file. Sometimes we get STL, sometimes we get REVITs. Sometimes we get SAT files, IGS files, IP, and it goes on. The list is pretty endless, and I'm sure many of you recognize a lot of these file formats. And the challenge for a company like us is if we're working with several different companies from several different industries, every single one of those files is different. Every single one of those files comes in a different way with a different way of trying to visualize that. But interestingly, the end result is usually the same. It's either in a rendered image or it's in a real-time or it's in a configuration. But it's a much more different process every time we have to take one of these. So what we found was quite an interesting thing to dig into was how do we align on what are the goals and the priorities? Because it's all well and good to take this input data, but what's the end result? What's the end use case? So the one I will dig into personally along here is about configurators. So at London Dynamics, quite a lot of time we build configurators for different companies, whether it's an automotive or it's a boat. This is an example of a bicycle. Now what's very interesting about this bicycle is the manufacturer only gives us the frame information. We have to get CAD data on the cogs and the pedals from a different manufacturer. We have to get the chain information from another manufacturer. It comes from different sources. And it sometimes comes in different file formats, and sometimes it comes in different shapes and sizes. Sometimes inches, sometimes millimeters, sometimes it's inverted, sometimes it's not. So it's quite a challenge to put it all into one thing, but the end result still needs to be the same. So even though in this example here we're just switching between different frames and different sizes and different cogs and different tires, they've all come from different sources and different backgrounds. So the end result can mean that we have to put a lot of work in, and of course with a configurator like this, it's hundreds of thousands of combination possibilities from different paints to different colors. You can customize everything on it. But Ashley, I'm going to hand over to you for you to talk about design iteration and business-to-business sales.
Yeah, so we work with a lot of industrial clients, and I bring this up with goals and priorities because kind of goal number one in that initial design phase can be just design reviews. So, perfect looking materials like your bike configurator aren't necessary to get the design review to happen, but it still needs to be web-based. So Aztec, they're really forward-thinking. They design everything in SolidWorks. They also use ANSYS, Altair, and MTech for simulation models. They are able to convert it to web-based to instantly do design reviews and feedback loops with their clients on web and in XR headsets. They also do LiDAR scans of existing plants to then bring that into SolidWorks and do retrofits of what they're going to change with the facility, and then do AR and XR walkthroughs with their clients. So it's really fascinating, and you don't need something that is photorealistic for that. It's about where is that part going to go, how is it going to fit, and they've been able to combine all these different CAD softwares and convert to a 3D visualization across devices. That has really moved the needle for their business.
Did they ever have a question for you? Did they ever have any? You talked about it's mainly for interior, for designing the products. Do they ever have any need to visualize it further and like do rendered images from it?
Yeah, they'll render images, but it's a lot more of how do you do that engineering walkthrough, especially if you design in SolidWorks and your client is a Siemens shop, right? And you need to convert that over. But maybe the stakeholder and budget holder, they're not an engineer. They don't even have Siemens or SolidWorks on their desktop, right? But they need to be walked through this, new tower that's going in their asphalt plant.
Yeah, right, wow. There must be so many. And how do they deal with like all the iterations? Because I guess with design, there's changes to the design along the process. Is it simple for them to just go backwards and forwards? And how, I guess, input in the design process, do they need things like SolidWorks and things like that?
Yeah, so the way, Aztec specifically works with us is, their engineer team uploads the recent design to our platform. You can update version control and then publish out to where you need. But, the one other goals and priorities I'd mention, because they're actually starting to develop a new revenue stream for their business, is real-time maintenance. So being able to send links to someone at a plant that owns their, cooling tower, and quickly be able to guide them through AR of how to fix that.
Nice.
Which is a new revenue stream, which, then it's easy to sell them software, right? Because they're making money on it.
Actually, on the bike demonstration I had a moment ago, they used to manufacture the bikes based on what they thought customers wanted, but through a configurator, they've actually changed how they manufacture because they found other people want other things now. So it's quite an interesting thing of taking all that data and go, there's everything, let the customer design on a system and on a platform, and then they've changed how they're building everything now because they thought something that wasn't needed is actually completely the opposite. So it's been quite an interesting journey for them. But like to Paul, sorry, it's to Eric. You're sitting in the wrong sequence, so I do apologize. Eric, do you want to talk a little bit about any challenges and processes around tessellation?
Yeah, so CAD data is usually parametric, right? You can do all kinds of parametric editing to the surfaces, but they're not really triangles. And when you go out to a real-time format or to a render engine, you need to have it in triangles or polygons. And so that's kind of a big challenge often. You need to figure out what resolution you want to put it out as. And if you have a gazillion parts, then it's, you run into limitations with real-time. How can you actually represent that in an AR platform or in a VR headset? You have definite limitations on how many vertices you can render. So a big part of it is how do you tessellate that surface, these parametric surfaces, and turn them into polygons? And then how do you simplify it enough that it can actually run and not tax your hardware, especially if you're going out in e-commerce to somebody on a cell phone, right, who's got a mobile phone and they want to view it in their space. They've got limitations on the CPU or the GPU in the unit, and then you've got heat, limitations. It's going to heat up the device and make it really slow. So decimating it down is a key issue you need to deal with. And so a part of our software is tessellating the incoming parametric surface, and then giving you different ways to do decimation and simplification, reducing the number of draw calls, which is like how many materials are in the surface. So like the car, for example, the door and the bumper might be a different material, but you can simplify it down into the number of materials that you want, that kind of thing.
And how do you decide how many polygons or materials it needs to be?
Yeah, so how many knots in a piece of string, right? It's like, how do you choose, right? So there's some general guidelines. Something we've been working on in the Kronos group calls is something called the asset guidelines, which is general guidelines for how to produce content that's going to work across multiple renderers and multiple real-time clients out there that you might want in your e-commerce. So we talk then about, what's a good polygon count, what's a good number of materials, that kind of thing. And we're working on those guidelines to update them to the current standard. I think we put those out like 5 years ago. Is that right?
Yeah,
Something
about
like
that, yeah.
So it's been a little while. Things
version,
have
yeah.
changed over time.
There's a link at the end of this presentation where you can contribute to that conversation as well. I'll come to that. But another thing in here, you've got about winding order. That's a problem we've often suffered with a lot, right? Where we'll get a boat, say half of it is facing a different way to the other half, and that can be a real problem, right?
Yeah, so, like the car on the left there, that's been tessellated out from, turned into triangles from the parametric data. But the parametric data doesn't really care about which way it's facing. You just render both sides at the same time. You render everything two-sided, and you don't see that problem. But then when you go out to a real-time format, well, then it cares about the sidedness, especially if you're baking textures from one surface to another, or baking ambient occlusion, which really increases the visual quality of the output. Then the sidedness really matters. And so we had to build specific tools that try to detect which way those triangles are facing, and then flip the order dynamically so that it kind of handles it and produces good output. And it's a hard problem to solve. It's really difficult, especially if you have transparent parts like the windshields and the glass. Then it has to look inside and see, well, which way are you really facing? If the camera's inside the model and you're inside looking at the instrumentation panel, then you want to see the other side of the windshield so it doesn't look like it's just not there.
Yeah, right. I mean, Paul, do you suffer with what you do? Do you have any issues with this kind of thing with winding order? Because we'll see more examples of your work in a minute as well.
Oh yeah, all the time. This comes up. I mean, it's just another consequence of having your infrastructure asset represented by multiple different disparate source formats, right? And nobody can agree on how things should be represented. And so you get to this hodgepodge, and you got to sort through it and figure out what it really should be.
Yeah. Okay. And then, we've also got in here as well about culling as well.
Yeah, so something we provide is, occlusion culling, which is basically saying if there are parts that are inside the model that you don't really need to see, then we can automatically cull those out based on, are they visible from the outside? And we, can look at the materials and say, oh, if there's glass here and there's actually seats inside of the car, you probably want to preserve those and not have those cull away. So then you have the choice whether to choose to have glass, an understanding of glass, or you can just say, hey, I don't care about the interior, treat glass as if it's solid and cull everything away. And that makes it a very performant model, so you don't have to have, say, the engine in there. No one's going to see the engine in an AR experience. You can cull it out. And you can put more triangles for the outside and get a smoother curvature of the model.
I guess, that also touches really nicely on the IP issue. So when we get CAD data from clients, one thing that they often ask us to do is strip out a lot of this internal stuff so there's no IP issues, because when we output, say, to a GLTF file, that's online. So we have to make sure we strip out anything that could potentially be replicatable and, secure their IP in a safe way. I mean, on the design process that we saw earlier, this must be a common problem, right?
Yeah, I mean, VNTANA does something very similar to what REVIT Pipeline is doing here. We call it OGR, remove obstructed geometry. And yeah, it can detect glass and transparency and keep things there. But that's something a lot of our clients want, and because you just want to walk a client through, you don't want to give them the design and they can go build it, right?
Yeah, I mean, I guess with like when you're doing design thing though, you still need those internal parts.
It depends on the stage of the system. So some of our clients are using us in that internal design review, and they're having people log into the platform and annotate and collaborate. And then you've got the stage where you're sharing externally, and so that is a highly optimized version that has all the internal stripped out. You can customize how much you optimize or decimate to what polygon level, automate texture baking, all that stuff. But it's all configurable, so it depends on what is that end use case. But I think it's interesting that you talked just previously about what that ideal standard is for polygons, because we have commerce clients too, and Amazon wants a GLB less than 100,000 megabytes, and Home Depot wants a USD file that's less than 3 megabytes. So like, I really hope we get there, but I have a feeling there's always going to be needed different versions.
Yeah, and I think it's also managing expectations of clients as well, right? Like, I know that when we've worked with automotive clients, they expect it to be at the highest fidelity all the time, and your car becomes like really heavy. So you have to find that happy medium between it being actually efficient and not taking forever to load. Compression's also played a really important part in that, but it's been quite an interesting journey of, no, we don't want to take it above a certain amount. They're like, yeah, but when I look at the side, I can see, like, when I go right up close to it, I can see this. It's like, yeah, but it's in real time, and it can be a real challenge, that can be. Actually, this takes us really nicely on to materials, because that's also a very important part of it. Do you want to just talk us a little bit through about this?
Sure, yeah. So I thought auto was the worst when it came to perfection until I met the Met, the Metropolitan Museum of Art, who's preserving all of their priceless art with 3D scans. And so, that's really interesting. 3D scans is a different problem. You end up with the photogrammetry asset. With design and our commerce clients, they're often designing in apparel programs like Clo and Browseware, footwear programs like Moto and Keyshot, but they're using pre-render materials, which then you need to convert to PBR. So that's a problem. And then with the actual industrial CAD assets, you need to add UVs or unwrap the UVs to then add materials. So it very much depends on the industry you're coming from. And I'm glad we did the poll, but we literally have everyone. So the one advice that I always give to every organization is to develop a standard material library that your team can pull from. Adobe Substance is great place to start. If you need to be specific, there's a lot of different ways you can scan materials and create your own proprietary library, but that really can help standardize across your business.
It's a really interesting point, that, because like we're working with a client at the moment where they've got a library that's a few years old, and they built it to a certain standard, and now they want everything to be built to a new standard at a higher resolution. And of course, they haven't got the original source data for those higher resolutions now, and they've got a problem, and they're kind of going, how can you fix this for us? It's like, we can't really. We can't just magically increase it from this resolution to this resolution and still...
Just use AI, Dan.
Yeah, automatically. That's not a bad idea. But it's quite an interesting thing, and it's quite an interesting journey, because how do you feel about, like, because obviously geometry seems nowadays be able to be processed a lot better than textures, right? If you look at the size of a GLB file, if you put a lot of textures on it, it's going to be pretty big, but actually if it's one texture or no textures and just geometry, it's a lot smaller. So in the design phase, do you have that kind of issue? Do you see what I mean? So like, transferring of that data and those files backwards and forwards,
from like the industrial clients we work with, no. I mean, right, like I don't care if that's the perfect looking shade of brown. I just care how everything fits together and if this is going to be functional and if the, physics simulation is accurate. But I think it's more like the consumer goods that, that really matters. I mean, Valentino red is Valentino red, and that has to be accurate.
Yeah, definitely.
Yeah, we run into that a lot with people that design shoes, for example. We work with shoe companies. I can't say which ones, but they care really a lot about those materials and how the accuracy of it is. So it's really about, you probably heard about digital twins, right? Digital twin is like a 3D representation of your product. Well, a lot of people start from CAD because that's the manufacturing data that makes it really easy to generate your assets, to generate the real product. And you want to basically take that data and reuse that data to create the commercial versions of the assets, the things that you use in commercials or on websites and renders or things that are client-facing. And so it's really kind of important to be able to convert that down from the CAD data into something like GLTF that's a real-time format that works kind of everywhere and works across the ecosystem.
I think it's also another interesting point of what's the use case, right? So we got clients who only want real time. We got clients who only want render. So the end result, especially on fabrics of sofas and chairs and things like that, is a very different experience in real time versus an experience in render, because you can throw so much at a render, but you can only throw so much at a real time asset without it being just far too heavy to manage. But actually, that kind of leads us quite nicely onto, Paul, your thing about delivery. You maybe just go into how do we optimize the files for delivery? I know you've got an example here, but maybe you could dig into.
You mean in terms of materials?
Well, I just mean in overall, because actually I guess we've talked about geometry, conversion, we've talked about tessellation, backwards facing things, we've talked about materials. At the end of the day, you've got to optimize everything for one total delivery, right?
Yeah, we do. What we use for that is 3D tiles and GLTF, right? They're kind of the obvious solution. They were invented to solve that problem, and we're not really in the business of solving problems other people have solved. Right now, that said, when we first started using 3D tiles, it was about 10 years ago, right? And our customers came to us and they had a real business need to be able to load these often massive infrastructure models onto some pretty crummy laptops, right? And visualize them, right? Yeah. So 3D tiles to us was the solution, but it was not standardized yet. At that point, I don't think even GLTF was standardized. And so we took a stab at using 3D tiles to visualize infrastructure models. Problem is that there are many features that engineers need from a visualization that are not supported even today in GLTF. Things like non-photorealistic materials, rendering the edges of surfaces. 2D is huge, of course, for CAD, right? So instead of trying to resolve that problem for infrastructure, we're kind of trying to build on top of what's been done by Cronus Group with GLTF and add the infrastructure perspective. So we've submitted pull requests to the GLTF specification to add extensions that allow you to encode the visibility of the edges and things like that. And so it's kind of a case of, we're not the experts at 3D graphics at Bentley, and we're not trying to be, but we are pretty good at infrastructure, right? So we're trying to contribute back to that ecosystem, the infrastructure perspective, and I think it's working out pretty good.
And what's your final delivery? Where are you going? Is it on web? Is it on mobile? Is it on?
It's everywhere. It's web, desktop, mobile. Yeah, but we use the same rendering technologies in general across all of this, and of course, because it's 3D tiles. You were not limited to a particular platform, right? So if you want to take your engineering model and visualize it in XR or VR, it's 3D tiles, and there are plugins for Unreal and Unity that can photorealistically visualize that in real time inside the headset, and so it's transportable in that format.
And do you have to, because obviously you're delivering to different end use cases, I guess you've got to work on levels of detail?
Yeah, it's all levels of detail.
Okay, so
3D tiles.
Because this example here is lots of polygons and maybe not so many materials, but there's a lot of materials.
Well, yeah, those are both challenges. Because our users are engineers, Their job is to make sure the bridge doesn't collapse.
Yeah.
They could care less about polygon counts and pretty materials. Eventually, somebody's going to want the photorealistic rendering of this facility, right? And at that point, we have to figure out, okay, well, what is the actual material? And that information is in the model somewhere, but it's really hard to find, right? Like if you could find the engineer who designed the facility and point to a pipe and say, hey, what material is that pipe? He knows, but it's like encoded in some weird string in the name of the thing. So you have to be able to extract it, and there's all the clues. So our solution to that is machine learning, right? If you can train a machine learning model to recognize those clues and tell you, hey, I'm like 98% certain that thing is stainless steel. Well, now you can apply that at render time and produce a convincing visualization of it.
Amazing.
Yeah, and 3D tiles is really cool. It's a great innovation on GLTF because it adds that whole level of detail structure. So you can represent the fullest resolution if the client supports it. And if your client is more weak, like an old laptop, then you get the smaller file, which is great, and it's really seamless, which is awesome.
I think it's also knowing, like we talked about already, just knowing what that end use case is, right? So we've had problems in the past where we've been working in everything for real-time delivery, and then the client says, actually, I'd like it also for rendering. And that means you've got to basically re-engineer your stuff. I mean, you've got the core data to work from, it's a lot easier, especially if you've got the CAD data to work from, it's easier. But if you know in advance, it's kind of easier to bring it down. Because I guess that must happen with you with this kind of thing, right? If you know they're going to want rendering, you can focus and build it in the right way from the very beginning, right?
Yeah, that's right. It's good to know the use case ahead of time, but of course for a given infrastructure model, there are multiple use cases, right? Those things change hands from design to construction to operations. And yeah, the data model has to support all the use cases.
Very good. All right, we wanted to leave a good bit of time for questions from the audience. Good to see some hands up already. We've done these panels before and we've left like 10 minutes and it was never enough, so we're trying to leave as much time as possible for some questions. There's one over there.
Who has a question? Okay.
Hi, Michael Williams, General Motors. Just a couple different questions for you, Ashley. You talked about Aztec, and you talked about the different OEMs that design equipment that are delivering these different type of data models to you. How do you factor in origins and datum points of these different models and bringing them into one environment? Because you're going to have supplier A that designs in one coordinate system that's not going to be relative to a plant floor location. And you might have another OEM that designs in a different coordinate system, and you're trying to bring this into that same environment. Like your bike example, how do you know that chain is fully constrained within your model without those origin points as a reference?
Yeah, well, Dan is the bike, but I can answer a little bit and then pass it to you. We do get a lot. We say we take everything in the kitchen sink, right? So we can take parametric files, convert them to tessellated. We're preserving all that metadata and storing it within our database and tying it to the 3D model. And then we've built automated optimization pipelines, but we made it really easy to customize a 3D pipeline. So you can say, I want to preserve all the metadata, I want to preserve the meshes and UVs and nodes, or maybe I don't. With that, you can also adjust the sizing of the asset. So you're right, like some might come in meters, some might come in centimeters. I was just working with someone who is bringing an asset into Navisworks, and like Navisworks has a known issue with like that, like he had to change it not from 1 inch but to like 0.9999 to like get it all. So every program kind of has that issue. Our way about it is saving all of the data that was in there and letting you control through our front end or API how you want to change it. But I'll pass it to Dan for how you did the bike.
No, but it's good to hear you say that because I think it's a different use case. I mean, the cogs, for example, they came from a certain manufacturer, and we had to get those from the client, so they had to request them, and they could only get certain files in a certain way. We then had to do a fair bit of manual work and use other tools like Rapid Pipeline and other tools to do the decimation and help us optimize them. So the total count, the polygon count, like we talked about earlier, was met. But sometimes we get XT files, sometimes we get solid assembly files, sometimes we get STLs. They come in different shapes and sizes. We had one automotive client who said they're going to give us their CAD data. We went through a lot of legal processes to get the CAD data, and they gave us Maya files. So it wasn't really CAD data. They were lovely Maya files built for visualization, and they were fantastic, but they were crazy heavy. So, we had to spend quite a lot of time manually going through that and stripping out what we did and didn't need. But that's part of the process. And there are some clients who know nothing about 3D, and they go, look, here's everything I've got from CAD and engineering. I've got everything I could possibly get for you. And there are some who want to learn and improve their process internally. Like the bike people were great because we can't work with some of these files. And then they'll go away and find us the right files in the right format so we can work with them. Because some even had their own proprietary internal ways of working with their CAD data as well.
Yeah, but Ashley was right. I mean, metadata is king, right?
Yeah.
It's all about preserving that data that comes in and being able to use it. But sometimes you just don't have the data, and you have to be able to edit that afterwards. So I think one key thing that we all rely on is open standards like GLTF and USD in order to move data between different applications. And so that's a key part of the pipeline, just being able to provide the data in an open format that then people can edit where they need to edit it.
All right. Who else has a question?
Hi, so I am a costume design student from UCLA, and I have this question because as a costume designer, I noticed that the design logic feels very different from CAD-based workflows. Do you have any insights on how to better align the communication across these two very different approaches to 3D modeling?
Are you using Clo or browser?
Yes.
Clo.
Clo and Marvelous Design.
Okay, Clo and Marvelous Design. Yeah. I mean, it makes sense they're different, right? Because they're designed to be able to give you the pattern file at the end of the day to go manufacture and sew the garment. So that's a very different physics than and a fabric physics than a building. I would say. When you're choosing materials within Clo, make sure you're not choosing render only, because it will not export, and you'll be frustrated. I know one thing on the Kronos Group roadmap is fur. Fur we still can't do in real time well. So there's just like certain restrictions, but it really comes down to the materials you're using, and I can send you. We have a whole Clo guide, so I can send you a link.
Awesome.
Yeah, we see that a lot too, where designers often create surfaces where you've got the outside material of the say a coat, and then you've got an inside liner, and those that intersect with each other when you try to decimate those, because now the surface details don't match the same kind of layout of the curvature and how many triangles there are. So we've developed a remesher that basically you can use a remesher that generates a new kind of a voxelized surface and then bakes all that data into that new surface. And so you don't end up with those kind of intersecting triangles because it basically recreates the mesh as a new mesh that works in real time, but it still preserves by baking all the original data into it. So that's something that's been really helpful for us for solving a lot of those, or like we see people use transparent like decals in order to put a logo on a surface or on a shoe, and how do you represent that in real time? Often that gets decimated down to a certain amount, and then it starts to interpenetrate with the surface, and you get all these like fighting errors, and it just looks terrible. But remeshing solves that because it creates a new mesh and then bakes down into it.
Yeah, and just to Ashley's point as well earlier, like in Kronos groups with commerce and formats, we're trying to look at one thing that's quite often come up is the apparel industry asking us, like, how can we do simulation in real time? Or how can we get fur to work in real time? How can we get physics to work in real time? One of the companies we were working with, they were asking us about how can we get the stitching to be so good. So they wanted it to be literally go right up close, because it's an apparel, it's a garment. So you've got to be able to go up close to it and look at the detail of the fabric. The problem is it makes the file huge. So we've been trying to do a lot of exploration into it. We feel like doing physics simulation of cloth is pretty complicated. We've seen some examples of it. It feels a bit rubbery, but there's a lot of work going on, but it feels like we're kind of not quite there yet in regards to that stuff. So, but we're doing investigation on it. Leonard, man in the blue hat.
So you mentioned physics, and I think this goes to Ashley and Eric. How much of your clients' work requires physics, and what level of physics do they want to see?
Well, from the fashion lens, if you design something in Clo or Browseware, you can re-simulate it on a avatar to see how it falls. And we do get that question of wanting to be able to do that on web, and we're just like, no, it's not possible yet. Stick to Clo. That's what it's done for. I'd say from our industrial clients, the web 3D visualization is more being able to walk through stakeholders, whether they're internal or external, through a project. And they're still going to rely on that SolidWorks or Siemens NX file for the physics data, or ANSYS for the simulation model. They're not expecting a web renderer to do that, as long as you can tie that data to that visualization in some way.
Yeah, that kind of gets to animation data too. Like, often clients will have animation data that they want to preserve, and you just have to optimize that down in order to work it in real time. Because again, it's about limitation of real-time rendering in AR and VR. So being able to optimize animation is a big key thing.
There's also been we've been doing a load of work looking into virtual try-on, and it's quite funny because it works fine for hard products like earrings and watches and glasses and stuff like that. But when apparel companies talking about physics and simulation, they're going to want to see that in glasses. And the processing power just to try and do it on a web-based platform is enough. You can't really do it. So it's going to be quite an interesting journey of how to actually get these garments to appear. There's been a lot of really interesting stuff around AI, though. I've seen some really interesting papers on AI doing that simulation rather than through a real-time thing, but yeah, let's see.
Yeah, you talked about fur. That's something that's really interesting. There's been a lot of work recently on Gaussian splats and NURFs, or neural radiance fields, for representing these kind of soft surfaces or surfaces with complex shine data. And so that's kind of another avenue of approach that Kronos Group is, that we're trying to focus on in the Kronos Group, as a way to render these really tough surfaces, and also make it something that's small enough to actually transmit, because it's basically tons of point data, right? It's all this, which is a point in space with transparency and material and reflectivity and all that. So that's an interesting area that I think we'll see a lot of growth in the next couple of years, representing these really tough surfaces.
Building off what you're saying there, Eric, like, what do you think the future beyond triangles and PNGs of the material for a given object? Like, is there growth beyond that for Kronos to say, hey, actually, we should move to this new format that's even better and even more efficient, or are we kind of stuck with the world of triangles and quads for the next
I think
decade?
people have pushed for getting rid of triangles for 30, 40, 50 years, right? But it's been around that long. And the fact that it's been around that long and the rise of PBR has made it really an effective and a fast way to render realistic surfaces. It definitely has its limitations, right? In terms of fur and fluids and all kinds of other things. But I think it's probably here to stay for a long time, just because devices need to have more and more, need to be more careful with their battery usage, and CPUs and GPUs are going to get smaller, and it's going to be wearables, and it's still going to, power is still going to be a problem for a long time to come. But I think, having mentioned Gaussian splats and kind of that technology is a way to get more kind of material data into our models and be able to represent them in more ways. So we're talking about it in the Kronos group and what's out there, and there's a lot of awareness of what's going on. So, I don't know, watch this space.
Yeah, there's been some amazing results with like radiance fields and NERF, but there's quite often the same problem statements come up every time, which is how can I colorize it? How can I customize it? How can I do stuff to it? How can I? It's a data set, right? So it's defined. And the good thing about 3D and polygons and textures is you can add to it, or you can improve upon it, you can customize it, which you can't currently do with those other technologies. But those technologies often evolve. And I don't think it would be that long before you do start to see the first one come out and it's actually customized by lighting and stuff like that. And then that would be groundbreaking, because then that will probably change the game quite a lot.
I think it also really depends on where it's accepted, because that 3D file is only as good as where you can use it. So the fact that, in 2019, every web browser adopted GLB. So if I have a GLB, I can publish that to web. If I'm a consumer good company, I need to be able to put it on my e-com site, my, Amazon, Google. So I feel like we're kind of in the stage where the major platforms have adopted this, and unless we have some major end platforms change it, there's not going to be that pull, So
Yeah, definitely.
Yeah, actually, in Bentley, you guys have been working on kind of standardizing Gaussian splats. I know that's Adam Morris's territory, but have you been a part of that, Paul?
I have not personally been involved in that process. I certainly trust Adam to make things happen there, and it's such a new thing, and it's moving so quickly that it's very encouraging.
Yeah, so to put some context there, Adam Morris worked at Cesium, and then Cesium was acquired by Bentley, and they've put forth a standard, which Kronos Group is working towards, to standardize how Gaussian splats are handled, and such that they can be transmitted and used by multiple renderers and all that kind of thing. It's just a really fast development in Gaussian splats and NERFs, so there's a lot there to cover and a lot to handle, but they're putting forth a really good first step towards standardizing it and a way to make it so that everybody can use this technology. So.
And it is a weekly conversation. So it's very much on the radar. It's every week it's discussed in the Kronos group, in one group or another. So, any other questions?
Yeah, there is any other question? I know that you had one.
Ah.
This is probably an easy one, and maybe just a point of clarification for Eric. You talked about decimating 3D models. This decimation is with the native file format. So I give you a SolidWorks file. You're able to decimate that file and still produce a SolidWorks file again?
No, so that's the key, is that when decimating, you're decimating triangles, and SolidWorks isn't triangles, right? So, or usually isn't triangles, right? You can come out with a DWG or something that has triangles in it. So yeah, I mean, we offer in our suite, you can tessellate right away to fine, medium, or coarse, so you can kind of choose the resolution that you want to deal with. And after the fact, you can change that resolution and say, oh, I really wanted coarse instead of fine, and then it goes back to the original file and reteslates from there. But if once you want to decimate, that's really a triangle operation. So.
Yep. Thank you.
There's an interesting use case that we have with a car company where they give us CAD data for so many different bits and pieces, and so we actually use Rapid Pipeline to throw the door through, and then we duplicate the door, and we tweak those values in Rapid Pipeline to get us to that right level, and then put it on. And then what you can do is you can start to merge all those different components together and see how it all works together, which is really powerful. It kind of gives us that tweakability of like to make it look really good and high resolution, but keeping the file count down as well, which is really good. There's a QR code at the bottom there. This is for the Kronos Asset Creation Guidelines, our new version. Now, we'll give you a heads up. It's a very messy, we're currently going through it. What we're looking for is contributions and insights or anything you think might be missed from that document. When you click on that link, it will take you to a GitHub repo. But if you just scroll up a little bit, there's a link to a Google Doc. Please add comments in. We welcome any comments and any feedback from anyone. Are we missing something? It's a very early document. Eric and Mike Fester and I and Matt from Amazon spent a lot of time working on it. But we'd like to get your insights, and we're hoping to launch it this year into a much more final state. Eric, anything to add?
Yeah, it's basically a way to kind of come to a consensus across. There's a ton of knowledge that we all have from dealing with this day in and day out, and so we're trying to share that knowledge, but also come to a consensus on, what is the standard that we want to use across multiple industries for material data, or for triangle counts, that kind of thing, and provide people some clarity, because it's a soup of data, right? What do I do in this instance? So we're just trying to provide some of that. And we've already done a lot of work on it when we did the first version of it, but it's just a ton of data. It needs to be kind of succinct and clear and easy to understand.
And because it's a point of reference, it's not we would recommend you do this, recommend you do that. It's a kind of like, if you want to make textures, here's some suggestions of our ways of doing it. We want to make sure that when we launch it, we haven't forgotten anything. So there might be something, because you'll come from different sectors, it might be something that you're thinking, please don't forget this particular thing. Lastly, just before we wrap up, we are at the booth 510. Please come visit us if you've got more questions. Thank you to the panel, and thank you to you. Thank you.